Number 2 talks about cumulative frequency curves. It's another way to interpret your information, your data that you collect. So you guys are going to learn how to graph and pull out different pieces of information from cumulative frequency curves. Please make sure you guys get down the goal. All right. The reason why it's called cumulative frequency curves is because it sums up all your frequencies up to and including, any new values. Okay, so unlike your frequency table, which just tells you how many pieces are in each class, the cumulative frequency will actually add up each frequency. To draw one, to construct a cumulative frequency curve, you want to construct a cumulative frequency table with upper boundaries of each class interval in one column and corresponding cumulative frequencies in the other. This should be on your first page of your foldable. Of course, you want to make sure you label your x-axis with upper class or whatever it is, weights, heights, shoe size, and then your cumulative frequency on your y-axis. And then you want to plot your points, beginning at the lower boundary of the first class and ending at the upper boundary of the last class. Now, we talked about lower and upper boundaries when we were doing our histograms. The same way we found those boundaries for histograms is the same way we do it for cumulative frequency curves. Okay, so that's a skill from that you'll need for this as well. Okay, so when we look at this example, okay, it says a supermarket is open 24 hours a day and has a free car park. The number of parked cars each hour is monitored over a period of several days. The results are shown in the table below, and we're going to organize this information to a cumulative frequency table and draw the graph. Okay? So, in order to make sure that we get our cumulative frequency curve, we need to know what our upper boundaries are, because that's where we're going to place our, those are actually going to be our x coordinates of all the points that we plot. Okay? So again, we looked at the number of parked cars per hour. As we see, the lower limit and upper limit do not overlap. So that means that the upper boundary has to be what? 49.5. Remember, it's the midpoint between the upper limit of one class and the lower limit of the following class. Let's keep going. What's the next one? 99.5. Very good. 99.5. The next one? 49.5, and it continues like that for all of the classes. And then, of course, we do need the upper boundary of the very last class. What would that be? 399.5. Very good. Now, the one thing that you never want to forget about as well is the lower boundary of the first class. Okay? As we can see, it goes all the way to 0, and we do not look at negative number of car parks or anything like that. So the lower boundary here is going to be at 0. So in other words, where you're going to start your cumulative frequency curve is essentially going to be at 0, 0. Now, it will not always be 0, 0. You do need to look at the lower limit of your first class. Because if this was, say it was 5 to 49 instead, then the lower limit would be what? Or the lower boundary would be what? 4.5. Exactly. It will still follow the same pattern as before. Yes?
If your lower boundary isn't 0, does that mean you're going to have to do like a break in the graph?
It depends on where this starts. Like if it was at 5, for example, you probably wouldn't have to do a break because it's so close to 0. But the starting point would not be at 0, 0 like this one's going to be. It's going to be at 4.5. And so then it will start.
Because you can't have like half a car, is that like affect how we should like write our ice and upper boundary and all that?
No, it will not affect your upper boundary because this is for drawing our cumulative frequency curves. Now, when it comes to answering any further questions, like what we're going to do after we get our cumulative frequency curve, then yes, because like you said, we can't have a fraction of a car. So it's either going to be 100 cars or 101 cars.
So if we were drawing like a histogram of this, like we would draw with all of so 45.
You would still have your upper boundaries the same way. Yeah, you still have it the same way. Other questions? All right, now for the cumulative frequency column in this table. Okay, cumulative. You are continuing to add your frequencies as you go along. Okay, so if I'm starting at 0 and then I have 6 cars, or 6 for the number of cars parked between 0 and 49, this becomes 6, and then I continue to add to get the next part of my cumulative frequency table. So I'll do 6 plus 23, which is 29. I'll continue to add from there. 29 plus 41 to get my next value. 70. 70 plus 42 to get my next value.
112.
112. And I continue to do this throughout my table to get my cumulative frequency. What's 112 plus 30?
142.
What's 142 plus 24?
166.
What's 166 plus 9?
175.
And what's 175 plus 5?
180.
180. Okay? 180. And so what we've created here are basically our coordinates that we're going to plot to create our cumulative frequency curve. Okay? Any questions on that? So, let's go ahead and let's plot this cumulative frequency curve, okay? Like always, we'll need an X and Y axes here. So let's go ahead and let's draw that in. And how are we going to label that?
For X, we're going to use the cumulative frequency.
For X, it won't be cumulative frequency. That's for the Y's. For the X, we're going to put what? Very good. And then on the Y, we'll put our if I look at my table, my number of parked cars goes all the way to 0 to about 400. And the way this is spaced out, I probably can do every centimeter is 50. Yeah? Which means that every line in this graph is how much? 10. And then remember, my y-axis is my cumulative frequencies, and that goes all the way up to 180. So I probably could space this out the same way, yeah? Every centimeter is 50. When you create your own, you come up with your scale and just keep it consistent, okay? Keep it consistent. There should be some type of pattern between each of your centimeters. In this case, I'm increasing by 50s every centimeter. 10s are every one. Now it's time to plot my points. I'm at 0, 0 to start my cumulative frequency curve. The next point is 49.5 and 6. 49.5 is right before 50, just barely right before 50, and 6 is going to be halfway up into that box. And I continue to plot this. The next one's at 99.5 and 29. So 99.5 is almost right at 100, but just a little bit before. 29 is almost at 30. And we continue to plot. So go ahead and plot the rest of your points. 49.5, 70. I'm sorry, 149.5, 70. Now, this is a cumulative frequency curve. So when you are connecting these points, it should be drawn with a smooth curve. With a smooth curve going through your points. Okay? There should not be segments that connect all of your points. It should be a smooth curve when you draw one yourself. Okay? So, if you're using pen, please switch to pencil. Just in case you mess up, okay? Not my best curve, but there we go. Be a smooth curve connecting all your points. And that is how you draw a cumulative frequency curve. So again, this is how you create your cumulative frequency table, and the table is what is used to create your cumulative frequency curve. That cumulative frequency table comes from your normal frequency table, which was given to you. Everyone catching my drift?
Yes.
Okay. All right. Now, from your cumulative frequency curve, you can actually interpret your graphs and find out different pieces of information. Cumulative frequency graphs are used to estimate percentiles as well as quartiles. Okay? Percentiles separate the data into hundreds, whereas quartiles separate your data into quarters. There is such a thing as called your lower quartile. That's your 25th percentile. That's known as Q1. Your median. I know you guys know about median. You did it probably a long time ago in like elementary school, but the median is right there in the middle. The 50th percentile, so 50% of your data. The upper quartile is the 75th percentile. That's also known as Q3. Okay, that's also known as Q3. That is how I will use lower quartile and upper quartile as well. Median doesn't have a shortened version. It's just median or MEV. Okay? Some may be tempted to use Q2. Please don't use Q2. All right?
Whenever it says define, do we just put like estimate of percentiles and quartiles, or
Like when it actually define these things?
or is it?
That's probably
Oh, that's next. Yeah, that's next. Yes. All right. So to find these, your lower quartile, like I said, which is Q1, is the value on your curve that corresponds to n plus 1 divided by 4 on your cumulative frequency axis, where n is your total frequency. So that formula of n plus 1 divided by 4 is how you go about finding your lower quartile. So if we take the last example of the parked cars, and I asked you to find your lower quartile, you would use this formula to figure out, okay, where exactly does that exist on my cumulative frequency axis? So, N represents your total frequency. Look back at the last example. What was our total frequency in the last example? 180. So you'll do, bless you, 180 plus 1 divided by 4, and what do you get? What's 181 divided by 4?
45.25.
45.25? Now listen to me well. This is not your Q1. This is where you need to go on your cumulative frequency axis to find Q1. So this is not Q1. This is where you go on your cumulative frequency axis to find Q1. This is what I mean. I'm going to go back to my curve, and I'm going to go along my cumulative frequency axis to 45.25.
Yes.
Okay, so I'm going to go to 45.25. For me, 45, again, is halfway between 40 and 50, so it'll be about right here on my graph. What I do is I use my ruler, so I'm going to use my straight edge feature. You're going to go over along 45.25 to where it hits your cumulative frequency curve. Then where it hits it, you're going to drop down a perpendicular line and see at what point does it hit your x-axis. point is your Q1. On my curve, that would be 120. Your curve should be somewhere close to 120. So then the lower quartile, the Q1 for this particular set of data would be 120. This graph was drawn by hand, so they do give you a little bit of leeway. They'll say give or take a couple of units, and it varies depending on the graph. If they give you a printed cumulative frequency curve, though, the window is smaller. They'll say give or take like 1 or give or take 0.5. Okay? So make sure you do use a straight edge. Make sure you use a ruler. Draw your horizontal lines over. Okay? But again, this number is not Q1. The actual Q1 is the X value on the X-axis.
Why did you choose 180 again?
Because it's your total, it's your value, and it's your total frequency. So that was how many, that was at the bottom number of our frequency. Let's go. Your median, it is your halfway point. It is the formula n plus 1 divided by 2. And again, that's where you go on your cumulative frequency axis to find your median.
Does n still mean the same thing?
N still means the same thing. It still represents your total frequency.
Will it always mean the same thing?
Yes. Now, your total frequency will be different depending on the data that's given to you. So in our case, the same example, it was 180. So we'll do 180 plus 1 divided by 2.
90.5.
90.5. Now, this value is not your median. It is where you go on your cumulative frequency axis to find your median. So we go back to our curve. I'm going to use my straight edge feature, and I'm going to go to 90.5. 90.5 is pretty much right at 90. I'm going to draw a horizontal line over to where it hits my curve, and then I draw a vertical line down where it hits my curve. And that point on my x-axis is my median. So for me, it will be 170. For you, it should be somewhere around 170. If you get a curve, if you put your points in the right places. Yes. So the formula to find your median is n plus 1 divided by 2. N represents your total frequency, which you get from your frequency table. 180 plus 1 divided by 2 is 90.5. This value is where you go on your cumulative frequency axis to locate your median. So on your curve, you go along your cumulative frequency axis to 90.5, and you draw a horizontal line over to where it hits your graph. At that point where it hits your graph, where it hits your curve, you draw a vertical line down, and then that point on your x-axis is your median.
Are you wanting us to label this on like Q1 and median?
Yes, those same lines that I'm drawing are good for you as well, because that's where like the method comes in. Like you know exactly where you need to go. So if your value is off, they're going to base it off of the graph that you draw. Does that make sense? Upper quartile is Q3. It is 75%, so that's 3/4. N plus 1 on your cumulative frequency axis. Again, that formula is not your Q3, it's where you go on your cumulative frequency axis to find Q3. So that's 3 times 180 plus 1 divided by 4. And what's that value?
135.25.
0.25?
Yes.
Okay. Something's off there. So 135.75?
Yes.
Again, this is not Q3. It's what?
Where do you go on the graph to find Q3?
Where you go on your cumulative frequency axis to find Q3. So I go to 135.75. Again, I'm using my straight edge. 135.75. That's 130. Halfway through 130. Oops, I didn't change my color. When I hit my curve, what do I do at this point?
Go down to the x-axis.
You go from that intersection point down to your x-axis, and then that
230.
is my Q3. So for me, it'll be about 230. You're looking to see where it hits your graph, and that's how you find that piece of information. Percentiles. Percentiles, P%, is the value on the curve that corresponds to that formula, again, still on your cumulative frequency axis. So percentiles. You guys have taken the PSAT and the SAT before, right? When you got your score reports back, it said what percentile you were in. That percentile basically tells you that you scored, this percent more than the population that took it. So if you're in the 75th percentile, that means you scored higher than 75% of the people who took that test. So the higher the percentile, that's good. The lower percentile means you need some work. Yes? Okay. So if I asked you in any one of the problems, or if Ivy asked you in any one of the problems to find the 80th percentile, or how many cars were in the top 20% or something like that, you would use this formula here, okay? Where 80 would be your P, because it does need to be as a percent. So 80%. I'm just making this up. Again, N is still 180. You add 1 and divide by 100. Someone tell me, what is that?
Yes.
144.8. Again, this 144.8 does not represent the number of cars that were in the top 80 percentile or in the 80 percentile. It represents where you go to find the number of cars that make it the 80th percentile. So you'll go to 144.8 one last time on this same graph. 144? 0.8. So that's in between 140 and 150. I go over to see where it hits my curve. Again, I draw down a perpendicular line, a vertical line. And at that point, that would be my 80th percentile. So for me, it would be right at 250. So 250 marks the number of cars that's like at that 80th percentile marking. Questions on interpreting your curves. So you have all the pieces that you need to know. Forgot this one. I lied. Interquartile range, IQR. That basically represents your middle 50th percent, or your middle 50% of your data. You find it by subtracting your lower quartile from your upper quartile. So that's Q3 minus Q1. I think this is the only thing that's given to you in your reference book regarding statistics. Okay? So Q3 minus Q1 is how you find your interquartile range. This represents your middle 50%. So remember, Q1 and Q3, those break it up into quarters. So Q1 is 25%, the median is 50%, Upper quartile 75%. So the IQR is the middle 50% of your data.
So what's the difference between this and
No, the median represents smack dab in the middle. But the interquartile range will basically tell you, okay, 50% of your data is going to basically cover this many number of cars. So let's find our IQR. What was Q3 from our example?
230.
230. What was Q1?
120.
Okay. So if I subtract these two, I get what? 110. So that basically means that 50% of my data covers 110 cars that were monitored over the hour.
Seems so weird to make the graphs. It's like 110 would just be like here, we can like all this stuff.
Right. So if you look, how far back do I need to go? Here we go. So basically between this point and this point, that's 110 cars that were observed between that. That's what IQR means.
So on a test, how would you write that on the graph? Would you just do a bold line in a different color and then on the side?
So the indication. So the question was, how do I indicate that on my graph? The fact that you've already indicated where Q3 and Q1 are, it is the difference between those. So you wouldn't actually do what I just did by covering over it. You just show Q3 minus Q1, the two values in the units. Good? All right. Let's take a look here at this example. Okay, this is not the best photocopy of the example that I got because I don't know if you can see it, but I can. It's asking you from this cumulative frequency graph to find the median, interquartile range, and the 70th percentile. In order to do your formulas, you need to know what N is. N represents your total frequency. And since this curve represents your cumulative frequency, your total frequency is going to be that last point's location. What is that? 100 and what? It's 120. If you look at your scale, every 2 centimeters is 50. So that means that this one right here would be 125, which means that every line is 5 units. So N is 120. That means whatever X was, you had a total of 120 pieces of data. Okay? 120 is the value of N. It is the total frequency of your data. The last point on your cumulative frequency curve is always that total frequency. And so we found that by looking over and seeing that it was right below 125, and that was 120. So then we use 120 to find my median, my interquartile range, and my 70th percentile. What's the formula for median? N plus 1 over 2. So that's 120 plus 1 over 2, which is 60.5. So what do I do now? I find it on the graph. So 60.5, since this goes by 5s, 60 is 2 lines up from 50. I go over to see where it hits the curve, and then I go down. And I don't know if you guys can see it, but I can see it. There's like a little faint arrow because this is like pulled from a book, so it's like already done. So that will be what? Look at the scale. Does the scale go by?
It's like
32.5.
by 2.
It goes by 2s. So this can either be 34 or 35 because it's like not, I mean, it's also the copy. You can't really see it that well, but it definitely doesn't go to this point here. It's right before. So you can either say 34 or 35. No, don't do that. Just commit. I'm only going to say 35. What's my interquartile range formula?
Q3 minus Q.
So before I can even find my interquartile range, I have to find Q3, I have to find Q1, and then from there I subtract. What's the formula to find Q3?
N plus 1 divided by 4. 3 times N plus 1 divided by 4.
3 to find Q3 is 3 times that. What is that value? One more time. 90.75.
Yes.
So that means I go to 90.75 on my graph, right?
No. Wait.
Yes.
Yes.
Yeah. Okay. I thought we were just. Okay. So we're.
Then I drop down that vertical line. What value is that?
Really bad copy.
8.
What value?
46.
Be about 46. Now let's find Q1. What's the formula?
N plus 1 over 4.
What is that?
30.25.
That's my Q1, right?
No.
No.
You gotta find it.
You have to find Q1. Definitely make sure you peep the scale of your y-axis, so then that way you know where you need to draw these lines. What value is that?
25, 26.
25, 26. Based on my graph, I'm going to say 26. Not the best. But again, your lines support whatever decision you go with.
So that could be 27. A little after.
Next, I'm a little off. Yeah, we'll say 27. So then I subtract them. And that's my interquartile range.
Yes.
Last but not least, my 70 percentile. The formula is P times N plus 1 divided by 100. So that's 70 times 120 plus 1 divided by 100.
84.7.
One more time.
84.7.
That is not my 70 percentile. It's where I need to go to find it. So 5, 10, 85. So pretty much be like right at 85. See where it hits the curve. Drop down that perpendicular line.
42.
I'll say about 43. Here we don't have a label of what X represents, but of course if there was like cars or people or whatever, you want to make sure you include your units. Questions? A dice is tossed 50 times. The number shown is recorded each time, and the results are given in the table. Write down the value of N. What is N?
175.
N is what? 50. It's 50. Because remember, frequency represents how many times this act was actually performed. And since this dice was tossed 50 times, N is 50. That means that entire column of the frequency should add up to be 50. And on top of that, your cumulative frequency total, your value of n is 50. Okay? All your frequencies should add up to equal the top value of your cumulative frequency. Every time. Okay? So now we have to write down the value of A, B, and C. In A is the frequency for number 2. What was the value of A?
8.
8. Because remember, in order to get 14, I have to add 6 and the next value to get 14. And so A would have to be 8. Since A is 8, we can find B. How? By adding up all of my frequencies and subtracting it from 50 to find B. What do you get?
14.
14. So B is 14. And subsequently, you need B in order to find C, because C is found by adding 24 and 14, which is 38.
On B, I kind of did it a little backwards. I found C with doing like C plus Y equals 43, and then I used C with 38, so I did like 24 plus B.
And you still got 14?
Yes.
And that's fine.
So how do you write
B, you add up 6, 8, 10, 5, and 7, and then subtract it from 50. That's how we did it. Questions? Let's keep going. Let's do. Let's see. Do I already have one in here? I don't think I do. Okay. Yes, I will give you some simple. All right. Let's do this one. Let's do question 5. Look to where question 5 is. And I want you guys to give this one a try. So when it tells you create a cumulative frequency table, you want to make sure that it's just that cumulative frequency. That's what they're looking for. The first entry is going to be 3. What's the next entry?
7.
Keep going.
18. 41. 84. 96.
Those are your cumulative frequency values. That's what you're going to actually plot on your actual axes. But what's going to be my upper boundary?
28. 31. 34. 37.
Why is it all these values?
Because they are
Because they overlap, which means you're not going to have any 0.5s or anything in between, because the upper boundary of one class is the lower boundary of the next class. And so there's no need for a 0.5 or anything like that. And so for me, the way I decided to scale this was I decided to make a break because I couldn't fit all the way up to 50 basically on my x-axis was provided. So I did a break and I started at 25 to make sure everything could fit. And then I have to go up to 100. So I was going to do my y-axis by 10s because I believed if I went by 10s and made every line by 2, I could fit up to 100. So I'm using a bulk of my graph. So I'm going to be, what is going to be my lower limit though for my first class? Where am I going to start this graph at? 25 and 0. The reason why it's 25 is because, like you guys said, it overlaps. So if I actually had more data before 25, 25 would be that upper boundary of the previous class, so then that would be the lower limit for that class. So then I'm going to be at 28 and 3, and since every line on my x-axis is by 1s, and on my y-axis by 2s, 3 would be here. Then I'm at 31, 7, and so on and so forth. 37, 41. 69 and 40. But are you guys questions on how to create your cumulative frequency curve? You're going to need to say yes or no because I'm trying to graph this real quick before the bell rings. So then I try to create the smoothest curve possible to connect these points, 25, 0, and through the rest. And depending on how good your curve is going to depend on, not my best. Definitely not my best. So to find my median, what's n? N is 100. So then to find my median, I need to do 100 plus 1 divided by 2, which is what? 50.5. Remember, that is not your median. That's where you go on your cumulative frequency axis to find where it hits your curve. Don't forget, you always drop down a vertical line from that point. And for me, my median length for the salmon is going to be 38. Okay, that will be my median length. It'll be 38 centimeters. What's the formula to find interquartile range?
Q3 minus Q1.
Q3 minus Q1. So remember, to find Q3, you do 3 times 100 plus 1 divided by 4. What's that value? Say it again. 151.5. It's kind of large.
I got 75.75.
Make sure you add, multiply, then divide. So 75.5, that means it's going to be really close to 76. Drop it down.
I got 75.75.
And so it's going to be really, really close to 76, like right below 76. So for me, that'll be 41. Then Q1, the formula is 100 plus 1 divided by 4, which is what?
25.25.
25.25. And the same process over again. And for me, that would be 35. So my interquartile range would be the difference between the two, which is 6.
So the n is not the total of the cumulative frequency, but the total of the frequency itself.
Yes, the total frequency. So yeah, total frequency, not total cumulative frequency, but total frequency. So it's going to be the sum of all these, or it's going to be the last entry in your cumulative frequency table. That's also the highest point on your cumulative frequency graph is the value n. And a lot of times the problem also will say how many pieces of whatever they observed, and that will be your value n. But that's how you create, and that's how you interpret information from your cumulative frequency curves.